Here we're going to look at question 17 from section 2 of the ENGAA 2018 paper. So in this question we're told that we have oil being pumped through a pipe at a speed of 5 meters per second and that the pipe has an area of 0.6 meters squared. Then at a point X the pipe narrows until at a point Y when it becomes a constant width again with area of 0.25 meters squared. So we're also told that the density of the oil being pumped through is 800 kilograms per meter cubed. And then the question asks us, what is the resultant force as the oil moves from X to Y? So if you'd like to have a go at this question yourself, then please just pause the video now. Otherwise, let's have a go at it. So looking at this question, it might initially seem quite weird since you're being asked about this force, but it's not really very obvious where this force is coming from or what it looks like or anything. So to try and sort of get a bit of a sense for what's actually going on in the question, let's just explore the situation a little bit. So we know that we have this oil being pumped through, but as the pipe gets narrower, the oil can't just continue to flow through at the same rate because there's less of an area now, so it's going to have to flow through a bit faster. And this is all because the same volume flows past X and Y in each second. Right, the oil isn't getting compressed or anything, it's not disappearing, there just has to be the same amount flowing through the pipe at the two different points per unit time. So, let's think first of all, about the volume passing through X per second. So we have an area of 0.6 meters squared and the oil moving at a velocity of 5 meters per second. So multiplying these two things together, we're going to get that we have 3 meters cubed passing past X per second. Then, if we consider the next point through Y, where we know that the oil is going to speed up to this speed V, which we're going to label on our diagram, then passing through Y, we can do exactly the same equation, but with this new speed V and the same volume per second of 3 meters cubed per second. So rearranging this for V, we can divide through by the 0.25 meters squared to get that the new velocity of the oil is going to be 12 meters per second. So what's happening is that our oil is moving through the pipe, and then at this point where the pipe gets narrower, it's accelerating to this new velocity. So there's going to have to be some sort of resultant force, and it's this force that the question is asking us to find. Now let's think next about how we can actually find that force. So what is force? Well, there's a few different equations which we could think of, and the first of those is probably Newton's second law. Now most people think of this as being just F equals ma, but that's actually not going to be too useful in this case really, since we don't know the acceleration of the oil as it moves across this pipe, because we don't know how far this distance X to Y actually is, and we don't know how long it takes, and we also don't have like a set mass that we could really use that with. So we could think about Newton's second law in the more general form. It's actually the rate of change of momentum. Now why is this going to be useful? Well, let's consider the rate of the change of momentum first of all. So this is actually going to be dependent on how the mass changes and how the velocity changes. And we already know how the velocity changes. It goes from 5 meters per second up to 12 meters per second. But then this first part where the mass changes, we could actually just rewrite this slightly by writing this as the change in mass divided by the change in time multiplied by the change in velocity. Now, we already know that passing through the point between X and Y, or passing past each point X or Y, we have this volume of 3 meters cubed per second. So this is the rate of volume flowing through per second. To turn this into the mass flowing through per second, all we'd have to do is multiply it by our density, which we've already been given up here in the question of 800 kilograms per meters cubed. So multiplying this density by our volume per second, we get our mass per second, and then finding our change in velocity, we just do our 12 meters per second minus our 5 meters per second. So this force is just going to be equal to our density, 800 kilograms per meters cubed, multiplied by our 3 meters cubed per second, multiplied by our 7 meters per second velocity, to get our force being 2,400 multiplied by 7, or 16,800 newtons, So this is just going to be our final answer, and it's going to correspond with D given in the question.